So, multiply and divide rational expressions. A rational expression is a fraction that involves variables. Okay? And so, you have to remember the rules for multiplying and dividing regular fractions because I tell people the rules don't change when there's variables involved. When we multiply fractions, we multiply straight across. Okay, so when we multiply fractions, we multiply straight across. If there's variables in there, we still multiply straight across. We multiply horizontally, okay? When we divide fractions, keep, change, flip. Who remembers that? Keep, change, flip, right? You keep the first fraction the same, you change it to multiplication, and then you flip the second fraction, okay? If there's variables involved, you still do that same thing. What happens next is what's different. Okay, you know how to reduce fractions when there's just numbers, right? Divide the top and bottom by the same thing. Well, that concept still holds true if there's variables involved. You're technically going to reduce these fractions that involve these variables. In the terms of you're going to cancel factors that are the same on the top and bottom because anything divided by itself is equal to 1, right? And so that's the reason why we can cancel factors, because they're not canceling and disappearing in the sense that they go away forever. It's just that when you divide it by itself, it equals 1. So if you have the same thing on top and the same thing on bottom, you can, quote, cancel them because they're dividing it by itself and it's equaling 1. Okay? But this is where you have to understand only factors can cancel. What's a factor? Something that is not divided, multiplied to something else. You can only cancel factors. Okay, you cannot cancel anything that's added or subtracted to something else. Okay, and this is why, if you ever get confused, you need to think about this stuff in terms of real, regular numbers. Because a variable is a number. It's just a number. We don't know what it is, but it represents an actual number. So think about this. Think about this. And this is, if you can get this concept, it'll make this section a lot easier. Think about this. If I had 1 plus 2 divided by 3 plus 2, that equals 3 over 5, right? Okay. What a lot of kids will try to do is they'll cancel that. Okay, well, let's say we do. Let's say we take both the 2's off. Now what does this fraction equal? 1/3. Is that equal to 3/5? No. So you can't do that. However, if I had 1 times 2 over 3 times 2, now let's just multiply them. So that's 1 times 2 is 2, 3 times 2 is 6, right? And then you can reduce that, and that equals what? Now, so if I had it like this first, can I do that? Yes, because it's still equal. Okay? Because 2 divided by 2 is just 1, so it's like 1/3 times 1. So you can cancel factors. You cannot cancel things that are added or subtracted because it's not mathematically equivalent. Okay? So when you put regular numbers in there, 1 plus x over 3 plus x, you cannot cancel those x's. Because if that was an actual number, you wouldn't be able to cancel it. So you can't cancel it when it's a variable. But if it's 1 times x over 3 times x, then you can cancel it. Because of this reason right here. Does that make sense? Okay? So my little poster that says, every time you do this, a kitten dies. That's why. You can't cancel things that are added or subtracted. You can only cancel factors. Factors are things that are multiplied. So if you've got something that's added to something else, you can't touch it. Okay? Okay, so let's look at this first example. So we have 5 over 20p to the 4th plus 4p squared over 5. Now, I'm going to show you, I'm going to do one step that you're eventually going to not have to do anymore. But when we multiply fractions, we multiply straight across, right? So this is 5 times 4 times p squared. And all of that's over 20 times p to the 4th, and then times 5, right? Okay, so now we can start reducing, quote, canceling, okay? And so I know that I can cancel 5 and 5. 5 divided by 5 is 1, right? Okay, I can, what can I do with this 4 and 20? I can reduce that by dividing them both by 4, right? So 4 divided by 4 is 1, and 20 divided by 4 is 5. Thank you. I'm one step ahead of myself. 5, right? So that 4 and 20 can change to a 1 and a 5 because I just reduced it. Now your variables, you need to remember when you divide variables, when you divide powers, you subtract the exponents, right? When you divide powers, you subtract the exponent. And so your answer, sometimes the exponent's bigger on the bottom, like in this case. And so we do 4 minus 2 is 2, right? So my answer is going to be p squared. Do I put it on the top or the bottom? On the bottom, because my larger exponent's on the bottom. The reducing is still the same. Think about this. If with this 4 and 20, we took each one and we divided it by 4, right? So I got 1 and 5. Well, here's p squared and p to the 4th. If I divide them both by p squared divided by p squared is 1. P to the 4th divided by p squared is p squared. Does that make sense? Okay. So if you ever forget the rules, where does my answer go? It's the same as if it were a number. You're dividing the top and bottom by the same thing. So we're dividing them both by p squared. Okay? And so now my simplified answer, is there an equal sign anywhere in here? So am I solving for p? No, I'm simplifying. I can't solve if there's no equal sign. Okay? And so my simplified answer, what's left on top? Just 1, okay? Not 0. It's just 1. When you reduce, nothing reduces to 0. Okay? And so what's left on the bottom? 5p squared. Now, my answer is 1 over 5p squared. That is the simplified answer. The next part of this is they will say, state the excluded values. That means tell me anything that p is not allowed to be. Any value that p is not allowed to be. Well, when we look at fractions, 0 cannot be in the denominator, because if 0 is in the denominator, then it's undefined, right? Then it's undefined. You can't have 0 at the bottom. And so when you look at this problem, you look at every step of the problem, starting at the top problem, this step, and all the way to the bottom. What would make 0 be in the denominator? If p was equal to what? 0. If p was equal to 0, then it would be 20 times 0 times 5, right? And that would put 0 in the denominator. So p can be anything else except for 0. Because if it was 0, then that would make it undefined. Does that make sense? So this is my simplified answer, but p cannot equal 0. So if the directions say state the excluded values, excluded means what value of p can it not be, then you would say p can't be 0. Okay? Because if it was, then it would be undefined. All right? Any questions? And if you try to put this on a graph and you look down on the graph, at x equals 0, you would have an asymptote. You would have that graph would not it would go up close to 0, but it wouldn't touch it. Okay, if you looked at the table at 0, you would see error. Okay, because it's undefined if it's 0. Okay, now the second one is a division problem. So change flip. Okay, you keep the first one the same. So 10x over 19. We change the division to what? Multiplication. And then we flip this one. So it's 12x to the 4th over 2x squared. So we flipped it. That's how we divide fractions. We multiply by the reciprocal. Okay? And so now we need to just reduce everything. We need to reduce everything and figure out what's going to cancel and what's not going to cancel. And then see what we have left after our answer is simplified. Again, when I'm looking at this, what can x not be? X can't be 0. Okay, so in my answer, it'll be whatever the simplified answer is, x cannot equal 0. It can be anything else. It can be 1, it can be 2, it could be -5, it can be anything else. It just can't be 0. Okay? And so when I reduce this, I can reduce 2 and 12 from right here, right? I can divide them both by 2. So 2 divided by 2 is 1. 12 divided by 2 is 6. Okay? And then x to the 4th and x squared. X to the 4th divided by x squared is x to the second power. It's x squared, right? Because 4 minus 2 is 2. And does my x squared go on top or bottom? Top, right? So this becomes x squared, and this just becomes 1. Okay? And think about this. Okay? If anybody, again, I'm going to tell you another way to think about when you're dividing powers. X to the 4th is x times x times x times x, right? That's x to the 4th. X squared, which is down here, is x times x, right? So if I cancel those, this one cancels with that, this one cancels with that, what's left? X squared. Where is it? It's on the top, right? So your answer, when I say you subtract the powers and your answer goes where the larger exponent is, the reason is because that's where the leftovers are going to be. Does that make sense? Okay. So let me get back to the problem. So we still have 10x and then times 6 x squared. All that's over 19 times 1, so it's just over 19, right? Okay, so let's just multiply that. 10 times 6 is 60, x to the 3rd over 19. So this is my answer, but x cannot be 0. You see in my final answer, there was no x in the denominator, right? So you'll be tempted to think that there's no exclusions. But if x were 0, it would have been undefined in the very original problem. If x was 0, you couldn't do anything right now. Okay? So if x was 0 here, it would be undefined. So at any step in the problem, whatever value is going to make x equal, make your denominator equal 0, you have to exclude that value. Okay? And 60 and 19 can't be reduced. 19 is prime. So there's nothing we can divide it by except for 1 in itself. Any questions? Okay, so this is when we're doing these rational expressions when they're just monomials. Okay? Monomials meaning just one term. Now we're going to look at some that deal with binomials. Okay, this is where I said factoring is going to come into play. Because we can only cancel factors, right? I can't cancel this 4 with this 4 down here. I can't. It's with this. It's all together with this. So you can't do that. So we need to take these and we need to break them apart to their factors to where we just have something times something times something times something over something times something times something. And then you can start canceling and reducing. Okay? what I do is, you look at these. Now, these are all, these are all together, okay? So the first thing I do is put my parentheses around my stuff so that I don't mistakenly think that I can separate it, okay? And so this goes together, 4x plus 16. So what can I do with that one? How can I factor that? Greatest common factor. What's my greatest common factor? 4. So I can factor out a 4 out of this, and what will that leave me?
X plus 4.
Okay, so now 4x plus 16 will change to 4 times x plus 4. Okay, I don't have anything down here. It's already just a factor by itself. So that's over 4 times. Can I factor anything out of this? No, so it's just going to stay x plus 5. And at the bottom, what can I factor out? A 4. And when I factor out a 4, that's going to leave me x plus 5. Okay, so this 4x plus 20 becomes 4 times x plus 5. Okay? So this is what we're looking at, but remember, when you're simplifying, every step should be equivalent to the step above it. Every step, you should be able to put it right back to the step above it. Okay? And I could. If I distributed this 4, I would get 4x plus 16, I'd get that back. If I distributed this 4, I'd get 4x plus 20, I'd get this back. So I didn't really change it, right? When you factor in things out, you're not changing its value. But now I have, this is my new problem. So now I have 4 times x plus 4 times x plus 5. All of that is over 4 times 4 times x plus 5. Now I have a bunch of factors. I have a bunch of things multiplied to each other. We can cancel factors. Okay? So, this 4 can cancel with that 4. X plus 5 is a factor, right? So because it's a factor, I can cancel it with the factor at the bottom, x plus 5. Because anything divided by itself is equal to 1. X plus 5 divided by x plus 5 is equal to 1, right? Okay, so what I'm left with is just x plus 4 on top over 4. That is simplified. However, I need to state what x cannot be, if anything. So when you look at the first step, when I look down here, 4x plus 20, what would make it be 0? What would make 4x plus 20 equal 0? Well, if you don't know that right offhand, set it equal to 0 and solve for x. 4x plus 20 equals 0. So 4x equals negative 20. So divide both sides by 4, and x equals negative 5. So if x was negative 5, then I would have 0 in the denominator right here, right? So negative 5 is something that x can't be. So as part of my answer, I say x can't be negative 5. Okay? And if I looked at the factored part of that, I could have seen that. Because negative 5 plus 5 is 0. That would make this whole bottom be 0, right? I don't see anything else that's going to cause me to have 0 in the denominator, do you? No, because when I go to this step, negative 5, we already excluded that. When I go to this step, negative 5, we already excluded that. So that's it. So the answer is x plus 4 over 4. Don't put this equal sign, sorry. Comma, x cannot be negative 5. Okay. I want y'all to try this one. Now this is a division sign. So what are you going to have to do? Keep, change, flip. Okay, this one's going to stay the same. You're going to change it to multiplication, and then you're going to flip this. Okay, you can't factor n minus 2, so it'll just stay n minus 2. But you can factor these two at the bottom. Okay, that's 3 terms. What are you going to use? AC method. AC method to factor this. What about 7n minus 49? How are you going to factor that? Greatest common factor. Okay, so we have n minus 2 over. When I take this and I do the AC method, I have negative 21. My factors that multiply to equal negative 21, but combine to equal negative 4. Right. Positive 3 and negative 7. They can't both be negative, because if they were both negative, this would be positive 21. So positive 3 and negative 7. So this equals n plus 3 times n minus 7. Does everybody see that? Okay. And so I'm going to erase this real quick. All right. So then I have to change it to multiplication, and then I have to flip that second one. So when I flip the second one, 7n minus 49, I'm going to factor out a 7. And that's going to leave me with n minus 7 over 7. Right? So now everything's multiplied. I have n minus 2 times 7 times n minus 7. And then on the bottom, I have n plus 3 times n minus 7 times 7. So now that I have everything multiplied, I have all of my factors, I can go ahead and start canceling things out. So 7 and 7, that equals 1. N minus 7 times n minus 7, that equals 1. N minus 7 divided by n minus 7, that equals 1. So all I'm left with on top is n minus 2 over n plus 3. That's simplified. However, I need to say now, what's going to make n break the rules? Okay? What can n not be? Well, when I look right here, when I have a factor times a factor, just like we did in the warm-up, anything that's going to make one of those factors equal 0 is going to cause this whole denominator to equal 0, right? So if n was equal to negative 3, then this would be negative 3 plus 3, so this would be 0, right? So n can't be negative 3. So n cannot be negative 3. N also can't be what? Positive 7. If n was positive 7, then it would be 7 minus 7. And that would make this piece be 0, which would cause the whole denominator to be 0. So n can't be 7. Okay? And that's it. Those are the only two things that n can't be. Any questions? All right. So we got the hang of this? Think we have the hang of this? Okay, let's do another one. You know how to do this. You know how to do this. Put that whole thing over 1. You can do this. That was an element. Okay. So, up here we factor out our greatest common factor, which is x. So that leaves me with x plus 11 over x minus 2, okay, times 1 over, I'm going to factor out my greatest common factor, which is 3x, times x plus 2. I factored out a 3x right here. Yeah? This is 3x times x plus 2. So that factors to that. Okay? This factors to x times x plus 11. Okay? What is this factor to? X plus 2 times x minus 2. Over x plus 11. Does it help if I cross it out and then put what it factors to? Maybe that helps people to see it better. Okay? Now, we can cancel things that are multiplied, right? Right? So, x plus 11 can cancel with x plus 11. X minus 2 can cancel with x minus 2. X plus 2 can cancel with x plus 2. Now, if I stopped right here and I multiplied, I would end up with x over 3x. Okay? The x's can cancel because this is 3 times x. This x and this x. So now you're only left with 1/3. Well, that's it. But we need to know what are our excluded values? What can x not be? So, let's look. What would make this be 0? X equals 2. So x cannot be 2. What would make this be 0? X cannot be negative 11. Okay? So we already have the 2 down here, right? What about this x?
0.
A lot of you forgot about that one. If this x was 0, what would happen to the whole bottom? It would be 0 because it'd be 3 times 0 times whatever. So x can't be 0. And then x can't be negative 2. So this was a high maintenance problem. There was 4 different things that x can't be. Anything that's going to cause it, any value that's going to make it be 0 in the denominator, x can't do that. You have to look at every step and every denominator. Okay? You only want to look at it after it's factored, though. Okay? Any questions? Good job. Good job on that one. Do this one. Yeah. That's it. Yes. You have to... What are we going to have to do with this one? Guys, what are we going to have to do with this one? Flip it. What are you going to have to do with this one? Flip it. And then it'll be all multiplication. Okay, so let's factor each of these pieces. Let's factor each of these pieces before we flip it. So this, when I do the AC method, 4 and 3, one of them has to be negative. My larger one needs to be negative because it has to equal, when I combine them, it has to equal negative 1. So it's negative 4 and positive 3, right? Okay. This I can factor greatest common factor out. So I'm left with x squared plus 3. This I can factor out my greatest common factor, which is 2x squared. And that leaves me with 4x minus 2. No, sorry, minus 1. And I can't factor these, right? Okay, so now I'm going to keep change flip. Okay, so this is x plus 3 times x minus 4 over 8x squared. Now remember, factors are things that are multiplied together. Is 8 a factor? Is 8 a factor? Yes, it's something that's multiplied to something else. X squared is a factor. Those are all factors. Okay? Times. Now we need to flip this. So 2x squared over 4x minus 1 over x times x squared plus 3. Times. We need to flip this one. X plus 2 over 4x minus 1. Because it's division. You have to flip whatever's after the division sign. What? Oh, thank you. Gotta close the door. Can't leave it open. Okay. So now, let's see what we can cancel, if anything. So I can cancel
X plus 3.
Whoa.
No, just kidding. No, you can't.
4x minus 1 with 4x minus 1. The x squared. That's why I said, is that a factor? Because you need to recognize that. That's a factor because it's multiplied to something else. So x squared and x squared. And then 2 and 8 can be reduced. I can divide them both by 2. That would just give me 1 and 4. Okay? I can't cancel x plus 3 with x squared minus 3. Because in order for you to cancel it, it means you're taking that thing and dividing it by itself, and it equals 1. They're not the same thing. So you can't cancel those. Okay? So that's all I can cancel. So now I'm going to write what's left. So I have x plus 3 times x minus 4. And I go across times x plus 2. Over. At the bottom I have 4 times x squared plus 3. So that's simplified. That's as simplified as I can get it. The last thing I need to do is state all of my excluded values. All of the things that x can't be. So, when we go back up, now I'm going to look at the factored version, okay? But I also need to look at it before I flip them, okay? So, when we go and look at it, at the bottom, x can't be what? 0. Because if it was 0, it would make this be 0 down here. So, x cannot equal 0. All right? So, let's move over to our next denominator. X can't be 0, but we already said that. X can't be? How do I figure out what x can't be? Take this and set it equal to 0. 4x minus 1 equals 0. Whatever, when you solve for x, that's going to tell me what it can't be. So 4x minus 1 equals 0. So 4x equals positive 1. So x equals positive 1/4. So x cannot equal positive 1/4. Because if it would, this piece would be 0. And x can't be negative 2.
So you look at the,
You look at every step. Any step. If something's going to make the denominator 0, then it's undefined. So wait, we're not done. Let's go to this step. Wait, there's more. No, we're still stating the excluded values. X can't be 0. X can't be 0. We already said that. Come on, people. Plus or minus the square root of 3. Good job. Oh, good job. All right. So, x can't be plus or minus the square root of 3. Because if you put x squared plus 3 and set it equal to 0, uh-oh, that was almost right. X squared equals what?
negative.
Now what happened?
Plus or minus the square root of 3.
X can't be plus or minus the square root of 3. I. then we already said this, x can't be 1/4. Okay, this problem says the average cost of a snow tire is modeled by something. Okay, so let's put real numbers in it. The average cost is $10 for a snow tire, right? And then it says the number of tires bought is modeled by this. So let's say they bought 5 tires. And then they want to know, write a model for the total amount spent on the tires. So if the cost of the tire was $10 and they bought 5 tires, what would you do? You multiply, right? The cost of the tire times the number of tires they bought, right? This is going to be the same thing, except that they tell us that the cost of the tire is this, and the number of tires they bought was this. So to write a model for the total number of tires they bought, you would take C and multiply it times T. Now, they already gave you this stuff in factored form. They gave it to you in factored form. So when you plug this in, the total cost is C times T. So they take what C is and multiply it times what T is. And then what do you think they do then? They start canceling things out. T plus 75 cancels with T plus 75. Which leaves us with just this. So this is a model of what the total cost would be. Okay? So then they tell you that T equals 0 is 1980. And they want you to know how much was spent in 1988. So T doesn't equal 0, T equals 8. So you just go and take what you just simplified and you plug in 8 for T, and then that will tell you how much they spent. Okay? So they're not difficult. You just have to read the problem and then ask yourself, replace those crazy looking fractions with regular whole numbers and say, what would I do? What would I do? Okay, I'd multiply. So then multiply those two, which means factors are going to cancel. Okay? Yep. Just all the way down? Okay.